Hi, my name is Mary Lynn from the Danny Boone Bridge of the St. Louis County Library, and welcome to Science at Home, where I am going to present a science concept that you can do the experiments with from home, with things that you have at home, and you can even take them one step further. Today, we are talking about water surface tension. And so, our first experiment is I have this jar, and I'm going to put some water in it. I almost have it filled up, but not quite. There we go. Okay, and I'm going to put this piece of cardstock on the top, and then I am going to very carefully tip it upside down. Now, what's so special about that, you say? Oh, I'm not holding onto the card. That is very strange. Huh. Oh my goodness, what's happening? I poured water into the jar. I put a card on top. I took the card, tipped it upside down first, of course. And the water is staying in the jar. I wonder why that's happening. Do you remember what we're talking about today? Right, water surface tension. I wonder what water surface tension has to do with the water staying inside the jar. We'll talk about that again very shortly. All right. For this next experiment, we're going to get the camera up close so that you can see what's happening. Let's see how many drops of water I can put on this one penny. How many drops do you think I'll be able to put on the penny? What is your hypothesis? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you see that the water is forming a bubble over the penny? It's almost like it has a skin or a film over the top holding the water in place. I wonder why it does that. Do you remember what I said we're going to learn about today? Right, the surface tension of water. I wonder what surface tension has to do with the water staying on the penny. Let's see how many more drops we can put on. We were at 10, 11, 12, 13, 14, 15, 16, 17, the bubble's getting bigger, 18, 19, 20, 21, 22, oh my goodness, 23, 24, 25, are we close to your hypothesis? 26, 27, 28, 29, 30, wow, 31, 32, oh no, I need more water, 33, oh, 33 was the one that made the water all go spilling off the penny. Wasn't that interesting? Let's do one last experiment that involves surface tension. We'll do this one up close too. Have you ever tried a sink or float experiment? Here I have 2 cups of water and a couple of paper clips, all the same size. Do you think a paper clip will sink or float? What is your hypothesis? Let's try it. If I place the paper clip very carefully into the water, oh my goodness, look, it's floating. Were you right? Was your hypothesis correct? Let me try another paper clip. Only this time, I'm not going to be so careful about putting it in. It sunk. Why would one paper clip float and one sink if they're both the same size. Do you remember what I said we were going to learn about today? Right, the surface tension of water. I wonder what surface tension has to do with the paper clips, sinking or floating. Let's talk about the surface tension of water. Water tension is caused by the attraction of the water molecules inside the water, of all the different molecules. In the middle, the molecules are attracted to all the other molecules around it equally. So there is a strong outward pull from each molecule to the others. But when you get to the surface, there are no water molecules up above, they're only deep inside. And so the water molecules on the surface only have pull or forces going down into the water. So that causes kind of a tension, a pull towards the center around the outside of the water. And that is water surface tension. Now, what does that have to do with our experiments? So, with the jar, it has a little secret that kind of makes it like a magic trick. If I take this lid off of this, you can see that there is a screen inside the lid. Can you see it kind of? And that gives a reinforcement of the surface tension of the water in the jar, so that when it gets tipped upside down, with the reinforcement, it can actually hold that water all the way through that jar. Pretty cool, huh? Now, the water on a penny is almost exactly, well, it is exactly like my diagram here. See how this is a bubble? That's what happened on our penny, right? It's because those ones on the those water molecules on the top are getting pulled down into the water molecules in the big drop on the penny. Eventually, when you put too much water in, then the surface tension just cannot hold it in anymore, and it spreads out and runs away. So that's the explanation of this water tension on the penny. The last one that we did was the paper clips. And that one is an interesting one. When I put the paper clip in very gently into the water, it floated. But if I just dropped it in, it sank to the bottom. When I put it in very gently, that was the secret, because I was being very careful of the surface tension. And setting that paper clip on that surface tension very, very gently made it able to float. It did not break that surface tension. Insects use that surface tension sometimes to walk on water. It's an interesting thing. Now, remember I told you that I wanted you to be able to try these experiments at home, but I also want you to be able to take them one step further. So here are some ideas that I have for you. You'll probably come up with some other ideas of your own. For the jar, you could try some different sizes of jars. Here I have a smaller one, and this one's not quite as the big one I had, as big as the one I had. A little bit smaller, but this one's quite a bit smaller. This one's glass. This one's plastic. I wonder if that'll make a difference. Another thing you could do is you could change the screen. The screen that I have in my jar is like a window screen, so it's pretty small squares. You might try a screen like this that has larger squares and that even changes shape of those holes as I stretch it. So I could try it in different ways. I could stretch it more or keep it tauter. And you could even try this over top of some unsuspecting adult's head. Remember, it's a magic trick. I would suggest you do it outside though, and make sure they're okay with getting wet, just in case things don't work out quite right. All right, for the water on the penny, how many drops on the penny? Here's some suggestions I have. You could try a shiny penny or a tarnished penny. I wonder if that would make any difference. You could also try a nickel or a dime or even a quarter, which is much bigger than a penny. I wonder if the size of the coins would make a difference, or maybe the metal that's in them. Interesting. Do you think a bigger coin would be able to hold more drops? Will it form the bubble? Lots of things to try. You could also try different liquids. So we know that water has the surface tension that forms a bubble. What if you use dish soap or cooking oil, like vegetable oil? Now, if you do those, make sure you have a grown-up's permission because they're a little messier than water, so I don't want you to get in trouble. Alrighty. And then the last one that we did was the paper clips. And so I was thinking, well, you could try different size paper clips. I have a bigger paper clip or a regular size paper clip, or I even found one that's coated in plastic. I wonder if that will make any difference to what happens with this experiment. You might find some other things that don't weigh too much and see how much weight the surface tension of the water can hold. Kind of interesting concepts. All right. Well, science is all about asking questions and then trying to find the answers. It's experimenting. So keep asking those questions, and thanks for joining me for Science at Home. Bye.